Hey everyone, and welcome back for another deep dive. Today, we're going to be looking at DC motors.
Yeah.
We've got a really interesting source here, all about a 3D model of a DC motor.
Okay.
And we're going to try to figure out how they work, why they're so important, and maybe where we can see them
Yeah.
in action every day.
It's amazing how something so simple can be so powerful, right?
Yeah, and they really are everywhere.
Oh, yeah.
So maybe we should start with like the basics.
Oh,
Like how do these things actually work?
yeah. So, our source talks about the key components like the rotor,
Yeah.
which is the spinning part of the motor.
Okay, so it's like the heart of the motor.
Exactly. Yeah. You can also call it the armature.
Yeah.
And basically, it's just a coil of wire that sits inside a magnetic field.
Ah, okay, so
Yep.
where does that magnetic field come from?
Right. So that's the stator. It's usually just a permanent magnet.
Yeah.
And it kind of sets up the playing field for the rotor.
Okay, I think I'm starting to get the picture here. So we've got this coil of wire sitting in this magnetic field. What happens next? I'm guessing electricity gets involved somewhere.
Yeah, for sure. So when electricity flows through that coil, it creates its own WN magnetic field.
Oh, wow. So it's like magnets all the way down.
Kind of, yeah. And that's where it gets really cool. It's like this invisible dance between two magnetic fields, one from the stator, one from the rotor.
So they're like pushing and pulling on each other?
Exactly. And all that pushing and pulling is what makes the rotor spin.
Wow, so that's how it spins.
Pretty much, yeah.
But wait a minute, wouldn't it just like get stuck? Like just going back and forth?
Oh, that's a great point.
Yeah.
And that's where this one super important part comes in, the commutator. Our source makes a big deal about this. It says without the commutator, a DC motor wouldn't really be a motor at all.
So what does it do? What makes it so special?
Well, think of it like a tiny switch. It flips the direction of the current flowing through the coil.
Okay, so as the rotor's spinning,
Yeah,
this little switch is constantly flipping the current back and forth.
exactly. And that flipping action is what keeps everything moving smoothly.
I'm not sure I totally get it yet.
Okay, so as the rotor spins, the commutator lines up with these brushes that are connected to the power source.
Okay, so the brushes deliver the electricity to the commutator.
Right. And because the commutator is split in half, it basically flips the direction of the current every half turn.
So that's how it keeps spinning in the same direction.
Exactly. Instead of getting pulled back, it keeps getting pushed forward. And that's how we get that smooth, continuous rotation.
That's so clever, like a perfectly choreographed dance.
Yeah, exactly.
Now, before we move on to like all the amazing things that DC motors do, there's something else I wanted to ask about.
Okay.
Our source mentions something called Fleming's left-hand rule. Sounds a little bit mysterious.
Right. It does sound kind of like a secret society or something.
Yeah.
But actually, it's just a really useful tool for understanding how electricity and magnetism work together.
So is it like a formula or something?
Yeah, it kind of helps us figure out which way the rotor will spin.
Okay, so if we know which way the current's flowing, and we know the direction of the magnetic field, we can use this rule to predict which way the rotor will go.
Exactly.
That's really cool. I love how something so complex can be explained with like a simple hand gesture.
It shows you how elegant these principles are. And speaking of elegant principles, our source also talks about this interesting connection between DC motors and generators.
Okay, are you saying that a DC motor can also be a generator?
Yeah, in a way, they're two sides of the same coin. They both rely on this principle of electromagnetic induction.
So in a DC motor, we're using electricity to create motion, but in a generator, we're using motion to create electricity.
Exactly.
That's amazing. So like if we spin the rotor mechanically,
Hmm.
instead of with electricity, we can actually generate power.
Yeah, that's the basic idea.
That's incredible. It's like a magic trick.
It is pretty amazing.
And I think this duality actually has some really interesting implications for things like renewable energy and energy storage.
Definitely, it opens up a lot of possibilities.
But I think we'll save that conversation for later when we talk about all the cool applications of DC motors.
Sounds good.
For now, though, I think we've covered a lot of ground. We've learned how DC motors work. We've talked about this fascinating connection with generators. I think it's time to take a quick break, but when we come back, we'll dive into the real-world applications of DC motors. And trust me, they are everywhere, so stay tuned.
Okay, so we're back, and I'm ready to talk about some of these amazing applications of DC motors.
Me too. They really are everywhere.
So we've already touched on like hydroelectric dams
Sure.
and electric cars, but where else do we see them?
Well, think about like robots, all those precise movements and robotic arms and stuff.
Yeah, that makes sense. They need a lot of control.
Exactly. DC motors are perfect for that. And it's not just like industrial robots. We're also seeing them in medical robots.
Oh, wow. So like in surgery.
Yeah, things like that where precision is super important.
It's amazing how this technology is helping us in so many ways.
Our source also mentioned hard drives and DVD players.
Oh, yeah, those spinning discs. They all use DC motors.
Wow, I never really thought about that.
They're kind of the unsung heroes of our electronics.
Yeah, like a whole symphony of spinning happening all around us.
Uh-huh. I like that.
And it doesn't stop there. 3D printers, drones, medical devices, they all use DC motors.
They really are everywhere.
So let's go back to that connection between DC motors and generators,
Yeah.
especially in the context of like renewable energy. You mentioned how hydroelectric plants use water to generate power.
Yeah.
So is that like a giant DC generator at work?
It's a little more complicated than that. Most large-scale power generation actually uses AC.
AC alternating current.
Right. But there are definitely cases where we use DC generators,
Uh-huh.
especially when it comes to things like wind and solar power.
Okay, so what makes DC generators good for renewables?
Well, think about solar panels. They actually produce DC electricity. So for off-grid solar systems,
Hmm.
we can use DC generators to power things directly or to charge batteries.
Ah, so we can skip the whole conversion process. From DC to AC and back again.
Right? That can save a lot of energy.
So from powering remote cabins to keeping our laptops running, DC generators are playing a big role in making our energy systems more sustainable.
Absolutely.
And let's not forget about like simpler applications, like that little dynamo on a bicycle that powers the headlight.
Oh, yeah, that's a classic example of a DC generator, turning your pedaling into light.
It's amazing how this one principle can be used in so many different ways.
Right, and at so many different scales.
So we've talked about a lot of cool applications, but you mentioned earlier that large-scale power generation usually uses AC.
Yeah, that's right.
Why is that?
Well, it has to do with the way we transmit electricity over long distances. AC is just easier to manage for those kinds of applications.
But is there a way to use DC for large-scale power?
Actually, there is. It's called HVDC, high voltage direct current.
So it is possible to generate and transmit DC power on a larger scale.
Yeah, and it's becoming more and more important as we move towards renewable energy.
Okay. I'm definitely interested to learn more about this HVDC stuff. What are the advantages over AC?
Well, one big advantage is efficiency. DC transmission loses less energy over long distances.
So like if we wanted to send power from a wind farm in the ocean to a city on land.
Exactly, HVDC would be much more efficient for that. And it's not just about efficiency. HVDC also gives us more control and stability, which is really important when we're dealing with things like solar and wind power.
That makes sense. They can be a bit unpredictable.
Right, so HVDC helps us smooth things out.
This is really fascinating. It sounds like HVDC could be a real game changer.
It definitely has the potential to transform our energy systems.
This is all so exciting. I can't wait to learn more about HVDC, but I think we'll have to save that for another deep dive. For now, though, I think we've covered a lot of ground when it comes to DC motors, and their amazing applications.
We've only just scratched the surface.
I know it's incredible how much there is to learn about these things. But for now, I think it's time to take a quick break. When we come back, we'll wrap up this deep dive into the world of DC motors, so stay tuned.
All right, so we're back. And I gotta say, I'm still pretty amazed by this whole HVDC thing.
It really is a game changer.
Yeah, I
See you,
mean,
Dick.
who knew DC power could be so powerful?
Right.
But I guess before we get too carried away with HVDC, maybe we should circle back to DC motors themselves.
Yeah, good idea.
For you, what was like the most interesting thing we learned today?
That's a tough one. I think for me, it's got to be the sheer versatility of these motors.
Yeah,
Yeah.
I mean, we've seen them in everything from tiny toys to giant industrial robots.
And medical devices and renewable energy systems, the list just goes on and on.
Exactly, and it's all based on the same basic principle. It's incredible.
It really is a testament to human ingenuity.
Speaking of ingenuity, I'm still thinking about all those potential future applications you mentioned.
Oh yeah, the stuff that sounds like science fiction. Yeah, exactly, like tiny robots in our bloodstream, or nanobots building things at the molecular level.
It's mind-blowing to think about what the future holds.
And then there's space exploration. DC motors are already being used on Mars rovers.
And who knows where else they'll take us.
It's really exciting to think about. Well, I think that about wraps things up for our deep dive into the world of DC motors. We've learned how they work, explored their connection to generators, and even touched on the amazing potential of HVDC.
And we only scratched the surface.
Yeah, there's so much more to learn about this stuff.
Definitely.
But for now, I think it's time to say goodbye.
Okay.
But before we go, I just want to say, the next time you see something spinning, whether it's a fan or a toy or even an electric car. Take a moment to appreciate the power of the DC motor.
It's amazing what these little machines can do.
They really are the unsung heroes of our modern world, so until next time, keep those minds curious and stay powered up.